We're starting chapter 10 here, which begins on page 261, and the topic of this chapter is public and private lands. How we manage lands both worldwide but also here in the United States is a topic that gets a lot of questions on both AP and ACE exams. So you need to be familiar with what different countries and what we in the United States here are doing to manage our land resources. There'll be a few laws that you need to learn about. There'll be a few agencies in the United States that we need to learn about, and a couple of key terms. If you look on the board in the classroom after you watch these videos, take a look at those vocabulary terms, because every word that's up there is a word that's been on the AP or ACE exam before. So you need to be very familiar with this terminology. Okay, I think this will be 3, maybe 4 videos altogether. This one ought to be a short one, so let's have at it. Let's start again. When I try to imagine the damage that humans have done to change the land around the world, I try to imagine Earth before there were people. Imagine what this planet would look like if there was not a human on board, and how much different the landscape would look, for instance. Would there still be forest fires? Would there still be mudslides and landslides and earthquakes? Yes, all of those things would happen. But would the consequences be different, for instance? I think maybe that's true. At the beginning of this chapter, we talk about the different ways that we affect land use, and here they are. Probably the single biggest damage we do to the landscape is deforestation, when we cut down trees. And all of that logging leads to, for instance, mudslides. We talked about soil erosion already. We don't need to go into that again. But that logging, that cutting down of trees, the lack of root support holding dirt in its place, leads to mudslides. Deforestation can also lead to climate change. Can you imagine why? All right, let's work backwards. Climate, here's that thing again. Don't show me this message. Let's work backwards. We talk about climate change, so we're talking about greenhouse gas increases because of human activity. The number one greenhouse gas that we talk about is carbon dioxide. How does cutting down trees increase carbon dioxide? Principally in 2 ways. One is the fact that those trees are no longer there. Remember, trees take carbon dioxide out of the air through the stomata on the underside of the leaves to do photosynthesis. They also need water, which they bring up from the roots. Carbon dioxide plus water yields glucose plus CO2, or I'm sorry, plus oxygen. So deforestation, the lack of those trees doing photosynthesis, increases the CO2 levels. But there's a second way that CO2 is increased, and that is all of the human activities it takes to cut those trees down. Think about the vehicles that have to be driven in order for these trucks to get to their assigned location to cut those trees down. Think about all the machinery. It all burns gasoline. It all emits CO2. Chainsaws, all the other logging type of equipment that's used all produces CO2. So that's 2 ways that deforestation leads to climate change. Landscape changes can lead to species extinctions. And not just that, I can think of another species issue that's associated with human activities on land, and that is the opportunity for exotic species to enter a location where they don't really belong. Paving can be a big problem when it comes to our environment, because all of that pavement, all of that concrete reroutes water, and runoff can happen in an unnatural way, In fact, you'll notice that whenever we design a city, one of the most important things that we do is figure out ways that we can reroute the water so it doesn't cause flooding in areas that we like. We also have this concept called the heat island effect. Have you ever heard of that before? Heat island effect is the added temperature that occurs around large cities. It probably wouldn't surprise you to know that downtown New York City in the summertime is 5 to 10 degrees hotter than the suburbs. All that concrete absorbs solar radiation. Even though it's white, there's still plenty of concrete that absorbs heat. Pavement, blacktop absorbs heat. All of those metal structures absorb heat. So we have something called the heat island effect. When you have a large city that's emanating really 10 degrees of more temperature every day, you can imagine that that has an impact on the weather in and around the area. And then we have the overuse of lands, and that leads to soil degradation. We'll talk more about that in this chapter. And of course, when we overuse the land, we end up with all sorts of runoff, and that causes water pollution. So there you go. There's lots of different ways that we have an impact. There are some pictures of such things on page 263 in your book. This is them. Here's a picture of a mudslide, and you can see this house has been decimated. I think you've seen some pretty good pictures of mudslide devastation over the past couple of years, probably, if you just pay attention to the news. In this picture here, we see land being degraded due to shifting agriculture. You know, the idea is these are people that are burning down and deforesting areas so that they can try to grow crops there. Here is one of the first famous endangered species cases ever. I think I've mentioned it to you before. The spotted owl in Washington State. And the fact that this creature will not nest in only but one certain area of the country in the northwest United States. And if those trees are gone, they become endangered. And that's exactly what happened about 40 years ago. The spotted owl was the first case to go to the Supreme Court under the Endangered Species Act. A logging company bought a mountain, and they bought that mountain to cut down all the trees off of it. And when it was discovered the spotted owl would live there and only there, the courts ruled that the logging company had to suspend its logging activities. And of course, that didn't make them very happy. They didn't think it was right that the government could tell them what to do with their land. As I said, there was the first court challenge to the Endangered Species Act, and the spotted owl won, which made the business community kind of upset. And of course, here's that urbanization we talked about, and the fact that when we put cities in a place like this, imagine what this looked like again. Imagine the earth without any humans. Imagine what this would look like. It's along a river, so it's probably be a forested area. Lots of forests, lots of habitat for creatures, good rich soil, all completely gone now because of urban development. So we're going to talk about each one of those things separately. But first, a very, very important concept in environmental science. It is called the tragedy of the commons. This is a term that was coined by ecologist Garrett Hardin. In fact, you should remember that. You should remember that Hardin is the guy that coined this term, tragedy of the commons. And what is a common? A common is any public area. Nobody owns it, but everybody uses it. One of the commons that I can think of that we've already covered is that largest aquifer in the United States. Who remembers the name of it? You need to remember the name of it. It's that funny name, Say it with me. Ogallala. The Ogallala Aquifer is a common. Belongs to all the farmers in the middle United States, and it is being decimated because everybody's using it to grow their crops. If nobody owns it, then who's going to take care of it? We have a tendency to take care of things that are ours, that we own, and we have a tendency not to worry about it so much if we don't own it. And that's the idea of the tragedy of the commons. In the example that they give here, the common is a grazing area. It's no problem when somebody's using the pasture in order to raise their sheep. But what happens when more than one person wants to bring in their sheep and graze on that same land? Pretty soon you get beyond the carrying capacity, and there is damage to the common, in this case the pasture land. And then we get to a point, of course, where everybody wants to be using this pasture because it's free, belongs to nobody. Well, then who's going to take care of it? Who's going to ensure that this pasture, that this grassland stays viable year after year after year? That's the tragedy. Tragedy of the commons is the tragedy that we overuse common resources, things that are common to us all. Nobody owns it, everybody uses it, nobody takes care of it. Well, you might say that might be a role for government, and you'd be exactly right. In fact, most of the rest of this chapter is about how we manage the lands to ensure that they're here for generations and generations to come, that we don't overuse a grassland or we don't overuse a forest. Tragedy of the commons. Here's another really new idea for you. It's called externality. And the idea behind externalities, it's the cost or the benefit of a good or services, but it's not included in the purchase price. I think I introduced you to this idea really the first day. Can you imagine if in the price of your quarter pounder with cheese, every expense that occurred, every damage to the environment that you could put a price tag on was included in the price of that quarter pounder with cheese? Or I'll tell you what, we're close to Thanksgiving. You know, we pay $1, maybe $2 a pound, maybe even less than $1 a pound for our turkey. $1 per pound, let's say. If we were doing full cost pricing, it would cost more than that. And these negative externalities are real. And right now they're costs that are paid either by everybody or the government. And if the government pays, it's through taxes. So if the government can't afford to pay, they're going to increase your taxes. So you come up with this idea of full cost pricing. Now, this is not anything that's going to happen, and I don't think anybody's really espousing it, because that would make everything cost way too much. But imagine if we could put a price tag on the damage to the environment, the amount of CO2 that came out of the tailpipe of the truck that delivered that turkey to Publix. A little bit of that CO2 and that damage to the environment ought to be added to the price. It's not, of course. That's the idea of full cost pricing. Those turkeys did damage to the soil, perhaps. Certainly they had to be shipped to some slaughterhouse somewhere. They had to be killed, and they had to be feathered, and all those other things. They had to be prepared for shipment. You know, they had to be beheaded, all those things that happened to those poor turkeys. Give their life so that we can have a nice dinner on Thanksgiving Day. But all of the environmental damage done in those processes ought to be included in the price of the turkey. That would be full cost pricing. Instead, especially when it comes to environment, we ignore these negative externalities and we allow society to pay for them. Here it says, because environmental damage for which no one bears the cost. But we will. And sometimes we already do. It all depends on what the environmental issue is. We're not paying the price for climate change yet, but somebody's bearing the cost for the damage to the land that's happening to raise those turkeys. And that's just one example. You go beyond food. Think of the environmental damage done in order for you to have that car that you drive. Think of all of the mining that had to occur in order to get that metal, and the landscape damage that was done. You know, that's all a cost to no one. But it is damage to the environment. If we were to put a price tag on that cost, that's the idea of full cost pricing. All right, another interesting concept. I believe I introduced this topic to you before. It's the idea of maximum sustainable yield. I talked about it in conjunction with fishing. And the idea is that there is a maximum amount of a resource. We usually talk about MSY in terms of trees and in terms of fish. You know, fishing, for instance, in a river or a lake or even the ocean. These fisheries have an MSY, a maximum sustainable yield. The maximum number of organisms or any resource that can be harvested without compromising the future availability. In other words, you never want to harvest more than can come back on their own by the next year. And that should just make sense. If you're a fisherman, you don't want to catch every fish in the ocean. Yeah, you'll make a lot of money this year, but there won't be any fish for you to catch next year. So the idea is called MSY, maximum sustainable yield. And you can see here, in theory, the population grows at its maximum rate at about half of the S-curve. So it's during this exponential growth phase here. I'm trying to find my cursor. It's during this exponential growth phase here that optimum growth is happening. So the concept is, don't ever go beyond this, which is about half of the carrying capacity. Don't start getting up in here and you're running dangerously close to killing off all of the organisms, all of the resource that's in an area. So for years we've been operating fisheries and harvesting trees and forests based on the maximum sustainable yield, based on the MSY. Well, in the book they mention that perhaps we should be changing our approach when it comes to maximum sustainable yield. First of all, it's very difficult to calculate exactly what that number is. And so what happens if government officials who are managing the situation or keeping their eye on the situation fail to get the right amount? That's a problem. And if they're erring on the side of making the MSY too high, then there'll be a real problem the next year when it comes to a harvest. When we talk about harvest, like I said, we can be talking about trees, we can be talking about fish. The point here is, if that harvesting goes too far, then we run the risk of not having the organisms available next year or the year after. So we try, sorry about the dogs. So we try to manage our resources on the concept of MSY. And on the AP exam, they talk about something called OSY, which is the more appropriate thing to use in managing a limited resource like trees or fish. The O stands for optimum. So that's optimum sustainable yield. Instead of maximum, instead of trying to figure out what that top number is and being mistaken, the idea is to be a little bit below that. Be what's optimal, but not necessarily what's maximum in order to renew the resource. So the OSY is always going to be something lower than the MSY. If this were the MSY here, let's just say that this is the number that was determined to be the MSY. The OSY would be something lower. The optimum would be something less. And it's sort of just to be safe. If you're going to make a mistake about calculating what the maximum might be, let's calculate the optimal, which will be a little bit less than that. I don't know how long this video was. I'm sure it was short, but this is a good place for me to stop for today. So we will pick it up tomorrow when we talk about public lands and protected lands around the world. All right. Bye for now.
How could she tell he deceived her so well? She'll be the last one to know. Silence is golden, but my eyes still see. Silence is golden, golden.